So we should be recording and you should be seeing my screen. I shared my screen, but I guess I didn't need to. So anyway, by now you should have seen the presentation on what is a line, and you probably heard about misgraph. If you haven't seen either of those, you should still be able to follow along with this. It's really review material, which is why I did a video, because I'm not sure if I'm going to continue to do a lesson on this in class, because technically it's not a standard for algebra. But I did want to go over the very basic concept of what a line is, or creating a line, not really what a line is. That was the PowerPoint that I showed you already, or hopefully you've already seen. That's a recorded video. If you haven't seen that, you may want to go in and watch the recorded video, What is a Line? You may also want to watch the recorded video about misgraph, if you haven't heard that story yet in class. Normally I tell that one in class. So again, a line is just X and Y coordinates. They all follow a pattern, and the pattern is what makes those X and Y coordinates line up. So just as a real quick review, these are all coordinates. They're just points. Oop, let me pick a different color. So these are all points. They're just points on the graph, all over the graph. There's no pattern to them. They don't line up. They're random. They're all over the graph. But if we somehow had a pattern behind them, meaning that every X and Y coordinate had some kind of a relationship so that they were in order, you could kind of think of it, then we might get a different type of graph. Instead of the dots, or instead of the points being all over the graph, they might line up, and if they line up, then they wind up looking like a line in some cases. They get closer and closer together. There's no you can't see the space in between them anymore, so they look like a line. So the equation, so here we have an equation, a linear equation. The equation is really what the pattern is, or part of the pattern comes from the equation. The equation tells us where on our graph, so this is our graph, our coordinate plane, it extends forever in all directions, so these lines go on forever in every direction. And again, the X and the Y axis are sort of imaginary. They just help us to understand where the numbers, kind of where our data falls. You'll learn more about that later in another class probably. But the X and Y coordinates allow us to say, okay, well, if we have data, where would that data be on the graph? If we didn't have any numbers, or if we didn't have these two axes, these numbers going up and down and left and right, we wouldn't have any reference point to put data. But these two axes give us a reference point to put data. They're not real lines, like it's not that I graphed, neither of them. We use that information to be able to tell where would this particular line go that comes from that equation. And every equation with two variables, so we have two variables, every equation with two variables creates a line, as long as it doesn't have some kind of a squared symbol in it. If there's no squared symbol, then it's going to create a line, a straight line, I should say. All right, so we just have X and Y, there's no squared symbol, two variables, so we're going to create a line. This equation will create a line. So there's a few ways to create a line. Well, not a few, a couple of ways. One, there's a way to graph it straight from the equation, which we'll learn. This is in slope-intercept form. We'll go over that in class later. This first one, though, we don't really go over. That's why I'm doing the video. So what we can do is we could just say, well, you know what? If I knew a bunch of the X and Y coordinates, I could just put those on my graph somewhere, and I could just kind of see where the line would be. So as an example, I'm just going to fill in this T-chart right here. That's called a T-chart if you don't remember. And for every X variable, so I'm going to write a number in here. Whatever that number is, it has one and only one corresponding Y value. a number that is the only number that goes with this particular x. And the way we find out that y value is we just do the math, because it says right here that y equals x plus 1. So every time we create an x or we use an x like that, all we have to do to figure out what y equals is just do the math. Y is going to equal my x number. So in this case, my x is 0, right? And I just chose 0. Kids always ask, well, where'd you get the 0 from? I just picked a 0. I can pick whatever number I want because a line goes on forever, left and right. So eventually, there's always going to be an x value on that line. And that's hard to explain, I know, but just for right now, just follow along with me. I can pick whatever x value I want. I picked the number 0 first just because my math is really easy. So I plug in 0 for x. The rest of the equation is plus 1. So y equals 1. So that means I just write in 1. 1 is the only value y could be whenever x is 0. Because it's 0 plus 1. That's the only thing you can get from 0 plus 1. So let's try another example. Well, I should be typing this in because they're going to disappear every time. So let me type these numbers in. So if I choose an x of 0, well, that's pretty small, but I'll maybe make the font larger in a second. Then y is 1. Again, the x value I just chose, I can pick any x I want, but the y value, I had to do the math right here because that's what y equals, x plus 1. So I had to do the math to get the y value. So let's pick another number. I'm going to go ahead and increase the font a little bit. We'll make it 20. So I'm going to enlarge these real quick. So let's see if 20 looks okay. Yeah, 20 is not too bad, so we'll make it a font of 20. All right. So let's see if it kept 20. It did. So now, again, I'm just going to pick a value that I think will make my math pretty easy. So I'm just going to pick 1. All right. Well, if I do the math, y equals x plus 1, but I know my x value now is 1. So I'm going to plug in 1 instead of x, right? So this x value right here is going to be 1. And again, I just chose the number 1. I can pick whatever number I want for x. But the key is the rest of the equation is plus 1. So y now equals 2. So whenever x is 1, the one and only value y can be is 2, because I just did the math, and that's what I got, was 2. So I'll type it in right here, 2. So now I'm going to do a couple more. Again, I can pick a negative value for x. It doesn't have to be a positive value. I could even pick a fraction if I wanted to pick a fraction. But again, I'm trying to make my math easy, so that's why I'm picking these pretty simple numbers for x instead of trying to pick something complex like a fraction or something. So let's type in now 2. We'll just keep kind of going in order. So again, I do the math. And it's going to be 3. Y has to be 3. And again, that just comes from the fact that y equals x plus 1. That's the equation. Well, if I make x 2, then y equals 2 plus 1, which means if x is 2, y has to equal 3. And I'll do one more real quick. We'll just choose 3. And again, as you can probably tell already, or if you probably know, y would have to equal 4. Right? Because the only way I can do this is, so I'll get rid of all of that. If y equals x plus 1, which I'm just getting from that formula that I started with, Well, if x is 3 now, then I'm going to replace x with 3. The rest of the formula is plus 1. Well, when x equals 3, y has to equal 4 because of the math in the equation right there. All right. So now if I wanted to, and this is how you create a line, basically we just plot the points on the graph. So we have 0, and these are just coordinates. So that's 0, 1. And by coordinates, I just mean points that are going to go on the graph. 1, 2, 2, 3, and then 3, 4. We just take this table and we just put it into a format where it looks like an x and a y value, a coordinate. So now I can plot all of these points on the graph. So I have 0, 1, which, oops, it's kind of hard to put it in the exact right spot. Let me try again. I have to make those dots a little bigger. 0, 1. Oh boy, that's not where 0, 1 goes. What am I thinking? 0, 1 goes right there. And then 1, 2, and then 2, 3, and then 3, 4. So those are not the best circles in the world, but I think you get the idea. That's where all of these points go. So it was x, y, and then 0, 1, 1, 2, 2, 3, 3, 4. I just took all the values from the table, I put them in the format of coordinates, and then I plotted those on the graph. So here I could even maybe color coordinate it a little bit. Oh, I don't even need to do that, I don't think. Oh, no, that's not going to work. Oh, well, never mind. I can't do that. I was going to make each dot a different color and each coordinate a different color. But hopefully you see that these dots right here came from these coordinates right here. All I did is I plotted them. And remember, when we plot a point, we go left and right first, just like I went left or right to get to the elevators. Then we go up or down. So we go to the 0 first here, then we go up to the 1. So 0, we didn't move anywhere, and we just went straight up to 1. Then in the second point here, we go to 1 and then up to 2. That's how I get this point. And then in the third point here, we go to the x of 2 and then up to the 3. And then in this point here, we go to the x of 3, left and right to 3, or right to 3, and then up to the 3 right there, the last point. So now, and I'll do it in a different color, we can draw a line. Actually, I'll use the actual line tool, I guess. And we'll just draw a line straight through these points. I'll actually move it a little bit up to where it should be. And we've created a line by just plotting points on the graph. So that's one way you can create a line. You just find x and y values right here. Whoops. You just find x and y values that make the equation true. The way we found those is we just plugged in a value for x, and then we did the math right here, x plus 1, and that gave us the value for y. That's how we found all of these values right here that I'm circling. And then we just put those values on the graph, and sure enough, they lined up and looked like a line because they all follow the same pattern. Every time you're just adding 1 to the value that x is. So real quick, I'm not going to do a whole lot of explaining in the next couple, but I'm just going to show you that this works every time. So let's change. I meant to change the equation. So this time we'll do x subtract 2. So this time we'll do a subtraction, and we'll say subtract 2. So again, I can create a bunch of x and y values. This time I'm just going to write into the table. So 0. So if x is 0, that means my y value would be 0 subtract 2, because this just comes from the equation right there. and this is my x value now that I just plugged in. So I just plugged in the x of 0. Well, x subtract 2 is negative 2. I don't have to go one by one. I could pick an x of 3 if I wanted. Let's pick an x of 1. Oh, I'm sorry, that is going one by one. Never mind. Let's go backwards. So let's pick an x of 3. Well, same math. If my x is 3, then I plug in 3 for x. I still subtract the 2 because that's still my equation. My equation never changes. So the subtract 2 will happen every single time. So 3 subtract 2 is 1. I could skip over and pick a 5. 5 subtract 2. Again, the subtract 2 never changes, is 3. And lastly, I'll just go to this, I'll pick a 6 there. And 6 subtract 2 is 4. So now I just need to plot these points. This is 0, comma, negative 2, 3, comma, 1, 5, comma, 3, and 6, comma, 4. I just took the table and I made all of the values into x and y coordinates. Boy, pen is not writing super well, so let's do that again. I should probably zoom in and it would work better. So I have 4 coordinates. If I plot those on here, 0, comma, negative 2 would be right there. It does not draw circles very well. 3, comma, 1. Again, I go left and right first. So I go to the right to get to positive 3 on the x-axis. And then from there, I go up 1. So that would put me right there. So now I can do 5, comma, 3. Well, I go all the way to the right to get to the 5. I'm trying to cover up my thing so I don't keep hitting with my arm. So I go all the way to the right to get to 5, and then I go up to positive 3, which would put me right there. And then last, I have 6, comma, 4, so I go all the way to positive 6 on the x-axis, so I'd be right there. That's positive 6. And then I would go up to 4, which would be right there. And again, as you'll notice, those all line up. And I have a line that goes right through all of those perfectly. So again, all you're doing is you're selecting a value for x. You do the math using the equation once you've, whoops, didn't mean to do that. Once you've selected a value for x, you just plug it into the equation, which is this part right here, and you solve for y. And that's how we get all of these values right here, is by solving for y. So if you haven't seen the other videos, you may want to watch the other videos. There will be a lot of these videos that are kind of like pre-work for your actual class lessons, since I don't necessarily have time to cover them in class.